Hello, higher physicists, and today we're going to have a look at the 10 commands. These are the words that the SQA use in their questions in your higher physics paper to tell you how to answer it. So, the first command word, state, name, or give. And this is where you have a question that's just going to ask you to present some information in a very brief form. There's no need for an explanation. So, for example, here there's a car coming towards a man, and it says the person observes the frequency of the sound changing as the car passes. State the name given to this effect. All you need to do, state the Doppler effect. 1 mark, easy peasy. Be aware though, sometimes you get questions a bit like this. State what is meant by an EMF of 12.8 volts. Because they've gone to the bother of writing 12.8 volts in the question, we need to have some information about that in the answer. So this isn't just asking me what is meant by an EMF, it's asking me what is meant by an EMF of 12.8 volts. So the actual answer would need to be each coulomb of charge receives 12.8 joules of electrical energy as it passes through the cell. If I don't mention that 12.8 volts or 12.8 joules, then I get no credit. Describe. You must provide a statement, what is happening, but not an explanation as to why. For example, here we've got a prism casting a spectrum on a screen. And then the prism is replaced with one with a different type of glass with a lower refractive index. And you've got to describe the difference. So how is that spectrum going to appear different? Well, if it's got a lower refractive index, the light's going to change direction less. So there are two things that really happen. The spectrum is going to be thinner, so the red and violet ends are going to be closer together, and the light's going to refract less, so the spectrum is going to appear less far down that screen. Either of those answers would be correct. I don't need to explain why that's the case, just that that is what happens. Number 3, explain. You need to tell the marker why something is happening. For answering one of these questions, it's probably easiest to say, as X happens, this causes Y to happen. For example, light from the sun is used to produce a visible spectrum. A student views this spectrum, observes a number of dark lines as shown. Explain how these dark lines in the spectrum of sunlight are produced. Explain. So I get 2 marks for this. As light passes through the sun's outer layers, photons of certain frequencies are absorbed. Okay, so 1 mark for noting that certain frequencies are absorbed, and 1 mark for noting that that happens in the sun's outer layers. Number 4, determine or calculate. This is the sort of question where you have to work out a sum. For example, calculate the gravitational force between a space probe and Mars. Calculate. I'm given the data in the question that I need. I also need the gravitational constant, which is in the data sheet inside the front page of the exam. So I put down my formula, I put the numbers into the formula, I work out the answer. 3 marks, bish bash bosh. Here's another one. This is given some data about 2 trolleys colliding together on a runway, and we've got to determine the final velocity of trolley Y. Determine. Same thing. Put down my formula, that gets me 1 mark. Put down my working, that gets me 1 mark. And then bash through the working and get an answer. And that gets me my 3rd mark. Estimate. You need to come up with an approximate value for something. And usually in these questions, in the marking instructions, there'll be some leeway in the answer. So for example, This question is asking you to work out the maximum energy that could be stored when a car slows down and the brakes turn some of that kinetic energy that the car had into usable energy. So what did I need to do? I'm doing an estimate question, and I need to work out how much kinetic energy a car had. To work out kinetic energy, I need to know mass and velocity. As I don't know either, I need to estimate them. So the mass of the car, I estimate about 1,000 kilograms. Speed of the car, I estimate about 30 meters per second. And then I work out the kinetic energy. Now, the marking instruction for this question had a range of values for the mass of the car, going from 500 to 3,000 kilograms, and the speed of the car, going from 20 to 70 meters per second. So obviously, there's not a definitive correct answer here. You were asked to estimate. 1 mark for the mass of the car, 1 mark for the speed of the car, and then a couple of marks for doing the calculation. Here's another estimate. In this one, we're given a graph of current against voltage. And it says solar cells have a maximum power output for a particular radiance of light. In this experiment, the maximum power output occurs when the voltage is 2.1 volts. Use the information from the graph to estimate a value for the maximum power output from the solar cell. So, estimate. Why is this an estimate? Well, if I have a look at this graph and look at 2.1 volts and then read across to the current axis, I see that 2.1 volts occurs at a current of between 34 and 36 milliamps. Therefore, I can't tell exactly that it is 35 milliamps. I can see it's between 34 and 36, and actually it's going to be less than halfway up the box. So I'm going to guess 35, but the SQA were allowing me a value for the current between 34.5 and 35 milliamps. And then I do my P equals IV sum, and that gets me my answer. That's why it's an estimate. Justify. You will need to state a conclusion and then give reasons to support your answer. So here, students are considering a plane traveling at 0.8 times the speed of light relative to a stationary observer. The plane emits a beam of light towards the observer. State the speed of the estimated light as measured by the observer. Justify your answer. So I get 1 mark for noting that the speed of light for the observer is 3 times 10 to the power of 8 meters per second. And I get my 2nd mark for saying because the speed of light is the same for all observers. That gets me my 2nd mark. There's a slightly different type of question here. This is a capacitor question. And what it talks about is the capacitor being discharged through this lamp. The lamp flashes and then turns off as the capacitor discharges. The capacitor is then replaced with one of 47 milliamps, about a third of what it was originally. And what happens to the time that the lamp flashes for? State the effect this has, that this change has on the time the lamp stays lit. You must justify your answer. Slightly different wording. The difference between a justify and a must justify question, as a student answering this question, there is no difference. You're still going to give a statement and a justification. As a marker, the marker will be looking more at your justification. You need the justification to have some correct physics in before you can get any marks. So it's a little bit harder to get the marks, but the way you answer it is the same. So I would say that the lamp will stay lit for less time because the smaller capacitor has less charge or energy stored in it. Because I've got some right physics in my justification, I can get both marks. Show that. You must use your physics or mathematics to prove something, for example, a given value. All steps, including the stated answer, must be shown. So here, show that the work done in accelerating an electron from rest is 2.6 times 10 to the minus 16 joules. These tend to be early in a question. Here it's part A1, because you're going to need to use this value later on. So it's better that they give you the answer and you show how it was got than you have to work something out and then potentially get it wrong and then use it later. But really, it's just the same as a calculated question. To get the marks for a show that question, though, you do need to show every step of working that you do. So my formula and my working, and then my answer. Second mark comes from the working, but I only get that second mark provided I show the correct answer as well. Technically, in a calculate question, you can get all of the marks for just writing down the final answer on its own without any working, provided it's correct. With a show that question, the whole point of the question is to show the working. So all of the working must be there and must be correct. Another one, a little bit trickier this time. You've got to show that the mass of a Higgs boson is 2.2 times 10 to the minus 25 kilograms, but you're told that its mass to energy equivalence is 126 giga-electron volts. And you know what a giga-electron volt is from the question too. So show that. First thing you need to show is how you convert the giga-electron volts into joules, and then E equals mc squared and do the sum. Otherwise, it's more or less the same as the last one. Number 8, predict. You need to make an informed suggestion about what might happen based on available information. So a student varies the angle of incidence and measures the corresponding angle of refraction. The results are plotted on the graph. Use the graph to predict the angle of refraction the student would obtain for an angle of incidence of 80 degrees. So if I look at an angle of incidence of 80 degrees and then scan my eyes up to the line, you'll see the line stops at 70 degrees. So I've got to predict what is going to happen. Here, I'm going to predict by continuing the graph on upwards and then seeing where that ends up. It looks like it's 41 degrees. The marking scheme, though, gave a little bit of leeway, so anything between 40 and 42 was deemed correct. 9, suggest. You need to apply your knowledge and understanding of physics to a new situation. A number of responses are acceptable. Marks will be awarded for any suggestion that are supported by real physics. For example, a car battery is connected to an electric motor as shown. The electric motor requires a large current to operate. Suggest why the connecting wires used in this circuit have a large diameter. So, why would we need thick wires? Well, I could suggest an answer that thicker wires will have less resistance and so are less likely to overheat. They accepted any of these answers. Wires of large diameter have a low resistance, or it will prevent overheating, or it will prevent the wires melting. And the last type of question is the using your knowledge of physics questions. And these are open-ended questions. You need to apply your skills, knowledge, and understanding of physics to respond appropriately to the problem or situation presented. For example, by making a statement of principles involved and or relationship or equation, and applying these to respond to the problem or situation. This is for open-ended questions. For example, a quote from a well-known science fiction writer states, "In the beginning there was nothing, which exploded." Use your knowledge of physics, comment on the above statement. Using your knowledge of physics. The marking instructions for these questions are like this. So if you demonstrate no understanding at all, you get no marks. If you demonstrate a limited bit of understanding, you might get a mark. Some reasonable understanding, 2 marks. A good understanding, 3 marks. It doesn't mean that you have to answer perfectly to get 3 marks. You just have to be good. So these are the 10 commands in your physics exam. It's almost as important to know what they mean as it is to know the physics itself. Because if you know what they're asking you, it means that you can answer and get the marks more easily.